Okay, you guys, in this section we're talking geometric applications of radicals. The goal is to solve applications of radicals involving triangles. The first application that you've already seen once this semester is the Pythagorean theorem. What does that say? Right, in relation to what, though? You've got to have well, not just any triangle, a right triangle, as opposed to a wrong triangle. No. What do we mean by a right triangle? It has a 90-degree angle symbolized by that little square right there. That angle would be the 90-degree angle. If the two legs are labeled, say, A and B, the two legs are the shorter sides. And the longer side, C, what do we call the longer side? It's the C is the hypotenuse, not the hippopotenuse. And you said it, I think it was Max who said it, A squared plus B squared is equal to C squared, right? That's only true if you have a right angle opposite side C, right? In the first example, we want to find the length of the missing side, and we kind of have a generic right triangle here. Shorter sides length A and B, long side length C. And you're told that A and B, A is 10 units, whatever the units are, B is 9 units. So find the missing length. Oh, I guess C is missing, right? So we can use that relationship, the Pythagorean theorem, C squared equals A squared plus B squared. And you basically just need to fill that in, don't you? Okay, fill it in for me. So fill in A, fill in B, you get C squared is equal to 10 squared plus 9 squared. But what is 10 squared? 100. What is 9 squared? 81. So C squared is equal to 181. But we don't want C squared, we want C. All right, well, let's think about this. Yesterday, if we had an equation like, so off to the side, if we had an equation like the square root of x equals, say, 3, what would you do to both sides to solve that equation? We would square both sides to get rid of the radical, right? So you would square both sides, and then you would end up with x equals 9, right? So that's just an example of maybe a really simple equation we'd get from solving radical equations, right? Well, now that's not what we have, right? This time we don't have a square root. We have we have the squaring function essentially. C squared is equal to 181. But as you know, the order in which you take a square root versus squaring doesn't matter, right? So in this guy right here, the square root of x, the whole thing squared, is the same as the square root of x squared, right? So, which, by the way, would equal x as long as x is non-negative. And, of course, we're assuming that we don't have any negative numbers here because we're dealing with lengths of sides of triangles. So what does that tell you we could do here? Instead of squaring both sides to solve the problem, what could we do to get rid of that exponent of 2? Go the other way around. What's the kind of the reverse of squaring? Which is what I was trying to get across with that extra example. Square rooting, right? So instead of squaring both sides to get rid of a radical, we're square rooting both sides to get rid of an exponent of 2. Makes sense, right? We're just reversing what we did yesterday. So we'll take the square root of both sides. So what's the square root of C squared? Assuming C is positive. It's just C, right? And the square root of 181, well, it's just, I don't think it simplifies. I think it's root 181. Okay, that's the answer. Now, you could always get a decimal approximation to that. You could plug it in your calculator, get a decimal approximation. But I think for now, we'll just leave it like that. Does that make sense? Yeah.
How would you want it on the test?
Oh, well, on the test, you're going to need both. This is nice because it's the exact answer. On the test, I'll probably ask you for both the exact answer and a decimal approximation. We could do it right now if you wanted. I was going to do a decimal approximation later, but we can do it right now. Just go second function, x squared, if you have a calculator like this. 181. You get about 13.45 if you round to 2 decimal places. And I'll say on the test how far I want you to round. So the approximate answer, let's actually put the approximate answer down here, is 13.45. So this is nice because it's exact, but it's also important to be able to get an estimate or an approximate answer. Part B, same triangle, but now you're given C is equal to 14 units and A is equal to 7 root 3 units. What are we missing? If you look at this picture up here, what are we missing? Looks like we're missing B to me. So it doesn't even matter, does it? If you know you're talking about a right triangle, just write down the Pythagorean theorem. A squared plus B squared equals C squared, and fill in what you have, and then it'll become apparent what's missing after you fill in what you have. So fill in what you have, what do you get? How would you write it? Before you evaluate anything, how would you write it?
7 root 3 in parentheses.
Okay, good. 7 root 3 has got to be in parentheses because you're squaring the whole thing. So that's A squared plus B squared equals 14 squared. Okay, now this is what you have to remember here. 7 root 3 is really a product. So when you square that product, you have to square the 7 and the root 3. So you get 7 squared times root 3 times root 3 squared. So how would that simplify? So 49 times 3, right? Okay, then you have the plus B squared equals 14 squared. What's 14 squared? Is that 196? Yeah. So then you get, just copying stuff down. You get 49 times 3 plus B squared equals 196. What's 49 times 3? Okay, so 147 plus B squared is equal to 196. Okay. So this is a little different than the last problem. Eventually, we're going to want to take the square root of both sides again, but you have to isolate the B squared first. That wasn't an issue in the last problem because C squared was already by itself. We were solving for C in the last problem. So you have to isolate the B squared before you can use that trick and take the square root of both sides to get rid of that exponent of 2. So how do we get 147 to the other side if 147 and B squared are attached with addition? How do we undo addition? So subtract 147. In other words, solve for B squared. Subtract 147. And you end up with just B squared on the left side. What's 196 minus 147?
49.
Oh, that's nice. 49. So what are we going to do to both sides again? Just like the last problem. To get rid of, we want B. We don't want B squared. So take the square root of both sides. That's reversibility and balance principle once again, right? You're squaring B. How do you reverse squaring? You take the square root. How do you balance it out? Take the square root of both sides. So we get, what do we get? We get B is equal to 7. 7 units. If the units aren't specified, you don't worry about it. But if they say the units are centimeters or inches or feet, make sure you write down the units in the final answer as well.